pass it over to you, Robert, and
Okay.
run with it. Thank you.
Yeah, is my audio okay?
To me, it's really great.
Great. So let me share the screen here and we'll get going. So, all right. All right. So, unfortunately, I can't see if anybody has a question in the chat. So, I think probably the best way to handle this is you can, I guess you can just unmute.
I'll watch it for you, and I'll watch it, and Jeff will watch it. So.
Yeah, we can just handle any questions that come up as they come up. That's fine. And also, again, at the end is great. So everybody can see the Sparky in my title slide. Did that work?
Yes.
Okay, great. So there's a lot of topics here. I could do a topic on any, Robert White, K0RCW. I could do a presentation on any particular aspect of trying to run my ham shack off grid and really bore you with all the details, or maybe interest you or fascinate you, I don't know. But there's a lot of different topics. There's a lot of detailed information available about every particular thing. But I thought I would talk to you about putting it all together. It's been a project of mine, probably going on 2 years, to be able to run my ham station completely off the grid for at least 72 hours. So let's look at actually what my goals were. So I have a packet station, and that's actually pretty energy efficient. We'll talk about sizing it in a minute. But I wanted to be able to run the station completely off grid for 3 days even without solar power. Which kind of leads into my second goal, which was to be able to run my packet station continuously forever. So you can just see at the end whether this has been achieved or not. Following on to that, being able to recharge basic electronics. And, if you're running a station, you want to log, you want to run FL Digi, you want to run Ham Radio Deluxe, you want to run Win for KX3, whatever, all these different programs. So you're going to need to have, in my case, I have a laptop computer, which is goal number 4. I want to be able to recharge all this wonderful stuff because nothing stops digital modes like running out of power in the middle of a QSL. And as you guys all know, these devices all require a fair amount of energy. So that leads into the question: how much power do I actually need? So, both kind of depends, right? So, my Kenwood, my UHF, my 70 centimeter 2-meter radio sits here and draws about 800 milliamps. It's kind of interesting, most radios, VHF, UHF radios have a low, medium, high, and in the case of this Anytone I've got here, like ridiculous speed, right? But most of them have 3 different settings according to what your requirements are. Just driving around town, I can hit W0TX repeaters with 5 watts generally. Every once in a while, I need to bump it up. Anyway, it's sitting here taking about 800 milliamps, drawing that. I have a flex radio for my HF, and of course, this is kind of interesting. So, whoops, if you could mute.
Jerome, can you mute your bumping there?
There we go. So HF, the wonderful world of HF. Now, you would think, and I naively thought, okay, if my flex takes 20 amps at 100 watts, it should take 10 at 50, and it's just not the case. There's quite a bit of overhead and I don't know about your HF radio. I'll talk to you about ways to measure that. In my case, there's actually an app, and then there's a piece of hardware. There's a variety of different ways you can measure current draw. But it still takes 17 amps at 50 watts output and 13 amps at 25 watts. So that was a little bit of a surprise. It's definitely not linear. And then, like I said, for the Microsoft Surface Pro is the laptop I chose. And there's a lot of older models which work equally well. I use it for some business purposes too. So it's over it's got too many steroids in it. But a 3 worked just fine, a 4 will work just fine, and it draws about 2 amps. And then, we've got miscellaneous electronics coming out of our ears. So the iPhone, the iPad, I don't know, the iPod. Uh, these all are like little parasites on your system, and they require, of course, they need to be recharged. I think the good news is that I can run my phone all day without recharging it now. I can run my laptop for 7 or 8 hours now without recharging it also. On top of backup for my ham system, these units all have their own batteries, of course. So that's a curse and a blessing, right? Because if you discharge it all, it's going to take that much more time to recharge. Total of about 9 amps. In my case, if I'm running a 20% duty cycle on the Flex. This is my dream scenario, to be able to run this forever off the grid and using solar. And you'll see that that's actually a tall order. And then there's the reality of batteries. So, we've had presentations on the various kinds of batteries, and I'm just going to hit a couple of the salient points, which are weight and maximum discharge capacity. So with the sealed lead acid SLA batteries or gel cells, you really can only use 50% of the rated number of amp hours on them. So if you buy a 50 or 100 amp hour SLA battery, I couldn't even lift that, I don't think. You really should only draw that down to 50%. Also, it weighs 40 kilograms or 88 to 90 pounds. So that's no bueno. I really don't want to go around picking that up. Neither do you. But we used to get free batteries at the DRC meetings, and so I use those for weights. They're fairly heavy. Just got rid of the last one. Just retired it. So the new technology, of course, is the lithium iron phosphate batteries. Wonderful stuff. Half the weight, and you can draw them down 90%, and you can get 1,000 cycles. So they're a lot more expensive, but you can cycle them many more times than the SLA batteries. So that's really, the economics start to work out more in your favor. They're not as expensive as they appear. So I don't know if you guys have killed a bunch of lead acid batteries in your life, your careers as hams, but there's a graveyard. Well, they've been recycled now, but there would be a graveyard out there. The other thing about LiFePo batteries is you cannot charge them at low temperatures, really not less than 5 degrees C, related to the chemistry that generates the power, right? So, the idea of putting those batteries out in a battery box outside is just a no-go. They need to be either in a heated shed or, But on the offsetting good side, they don't generate gas like the SLA batteries do, so they don't have that hazard. So, couple things about batteries. My high-end needs, as I said, would be 9 amps. I'm sitting here drawing 9 amps all day long. In reality, I wouldn't for 24 hours unless I were running in shifts at an emergency type situation. Now that adds up to an awful lot of amp hours. So here we are at 640. If I wanted to run my system for 3 days just on battery power alone, or whatever power, it would require 648 amp hours, and that's pretty tall order. However, my packet station only needs 1.25, and that's just the Kenwood running along and occasionally beaconing K0RCW out there. That could run quite merrily with just a fairly ordinary 100 amp hour LiFePo 4 battery. So that is achievable. Let's talk about solar panels. So, I didn't know anything about this. I still probably definitely have tons to learn, but learn by doing. So how many amps? I bought 2 Renogy 100 watt monocrystalline, and there's different chemistries for the solar panels available. These were like $125 a piece at Home Depot. So I got 2 of these panels, and I wired them up in parallel, and they produce in a perfect world that includes spherical cows, 10 amps. So if you wired them in series, they're each rated at about 20 volts. So you start wiring things in series, and you quickly begin to exceed the current capabilities of a lot of the hardware out there. So I thought, well, I'll just wire them up in parallel. So that's what I did. Then, we're at a fairly northern latitude here at about 40 degrees. That's not really, it just feels that way sometimes. About 40 degrees north here. So I went online, and that means that in the winter we get 9.5 hours of sunlight, and in the summer we get 15, and of course everywhere on the face of the earth gets 12 hours at the solstices. So what's really usable? Well, theoretically, in the winter I might get 5 hours of usable sun, and in the summer I might get up to 12. Um, so pretty quickly you can begin to see, and the reality is actually somewhat less than that because of an urban evil called trees. So we'll talk more about that scourge in a moment. But 50 amp hours are out there to be grabbed in the winter. Maybe a little bit better because there aren't any leaves on my trees, but right now it's no bueno. And summer, of course, with the longer days, it's better. So yeah, my setup is undersized, and not only do I suspect, I know it is. So trees, they are your enemy if you're a ham and you're trying to get solar power. So the shading affects the performance. I noticed in the last week or so that the smoke really affects performance. It degrades solar conversions by about, I would say, half. Um, we talked about wiring them in parallel. We talked about there's a little calculation. I have two 100-watt panels rated at 20.4 amps. So that gives me, or 20.4 volts, should say. That gives me 10 amps. If you look in that lower right-hand corner, you'll see one of my solar panels out on my deck that's shaded by the enemy. And then the cables run from the panels through this piece of PVC pipe I put through to carry all the cables into the house. The only thing I regret on that, I think that's a 1 3/4 inch PVC pipe, but bigger is better, guys. I spent a lot of time sweating it. I may have to drill another one because I keep wanting to run antennas through there. And you would think, the critters would crawl in there, but I put a piece of cloth in there and I've never had a problem. That piece of PVC has been in there 8 or 9 years, and it's been great, and it's still just as good as the day I installed it. So I highly recommend, if you want to put holes in your house, that's the way to go. A good way to go. Here's the panels. Nothing special. Got them off of this particular one I got at Home Depot. One thing I will add is that you want to keep them clean. So they're on the deck. The deck is adjacent to my shack, and so they're easy to keep clean. And the other thing here is that when you buy them, they come with these 10 AWG gauge wires and MC4 connectors. So, God knows that we all needed a new connector type, and here it is. So, and they have their reasons, but it just seems like I spend my life trying to mate different cable types together, and I have thousands of cables with convert A to B, B to C, C to D, and it's just not getting better, it's getting worse. The other thing I wanted a way to improve the angle that these panels faced according to the azimuth of the sun above the horizon. And I would have to experiment around with it this weekend to see if it makes that big of a difference. I think because I've got these panels on the deck, I don't think it's a big factor, but that's just an opinion. These came from China. They have sharp edges, so before you open up your skin, you want to file down the edges and the burrs on some of these drilled pieces. But once you do that, take 10 minutes to clean them up. Everything screws together fabulously. It's really kind of cool and kind of clever. Whoever invented this, and I just set these on my deck, and I put a bag of sand to keep, I don't think they blow over anyway, but it's you can put sand on there, or you can bolt them down. I don't really want to drive hardware into my composite deck, or to cut some holes in it for cables. So that's about all the violence I'm willing to do to the deck. You could put them on the roof if you want to put holes in your roof. All the usual things that go through a ham's mind. Bolt them to the car? Well, I don't think so. That's just a slick solution. And at the end of this presentation, I have a manifest that shows you what I paid for all this stuff, so you get some idea what you're getting into. I'll give you a spoiler, and that is that batteries are the single most expensive component to this whole setup. So these I think were about $25 for this, so not too bad. MC4 connectors. Okay, so here's the hard, your parents have that talk to you about the facts of life when you're a teenager. Well, the facts of DC electrical transfer, and there's a really neat YouTube video. If you go to YouTube and put in Yeti solar cable power losses, you're going to get an education, and it's really sad. So with a 15-foot run, you're going to have a 4% DC loss, but if you run them out 30, you try to chain those connectors together, and the guy even made a custom cable that was 30 feet long, and he's losing 37% on a 30-foot run. So, a real important thing to think about is how close can you place your stuff next to the how close can you get your panels to the ham shack? And I'm lucky because it's less than 10 feet. So, I'm in this 4% category, but it does limit your options. There's a special tool to attach and detach the MC4 connectors. I would say it's actually worth investing. I soldered my own custom Anderson. Yeah, it was. I hacked together. Okay, confessions, but I hacked together a cable and put some MC4 cables and the Anderson power pole adapter cable. But I would suggest that probably worth investing in getting that done, because that's a massive solder job, and I'm not that great at it. But it works. It works. Just trying to $20 here, $20 there, $20 somewhere else. And these projects, they're like Franken projects. They grow a budget of their own above what you expect. Let's talk about some fun toys. So West Mountain Radio, they should pay me to be on their sales team, but I really like this stuff. So this device is they're called their Power Check, and you can insert this anywhere in the chain of being. Okay, what I mean by that, you can put it between the solar panels and the controller, the solar controller, or you can put it between the power supply and the load, the battery and the load, and then the output of the power gate, which I'll also talk about, and the load. So I like to put this between the battery and the power gate, so that I know how much energy is coming out of the battery and how much energy is going back in. So you can do these projects all day long, but unless you know how much water is in my battery, how much energy is staying there, how much is getting recharged, how much is getting depleted, under what conditions, you just don't know what you're dealing with, right? So that was a big challenge of this project, was to wrap my head around that, and this little West Mountain Radio device that did that. It can measure volts, amps, amp hours, watts bidirectionally. So you see the little arrow on there in the video. So if under the word volts, there's two numbers. It'd be nice if it said amp hours, but you can see how many volts or how many of each quantity are going and coming to the load or away from the load. So this unit answers those questions, and it's really key to knowing whether you're succeeding or not. Otherwise, you run down an SLA battery, which I don't have, you're going to trash it, right? LiFePo 4 battery has circuitry in them, a good one, that most of them do, that protects it from over discharge, and that's a very nice feature. So revisiting my calculations, my setup, doing a 20% duty cycle and my 9 amps per hour scenario, the old joke about assuming a spherical cow. Perfect radiator it is. Under ideal conditions, I'm going to get my 5 hours. Yeah, sort of. One thing to consider, I can only recharge my batteries at a maximum rate of 10 amps. So right now I have a 100 amp hour and a 30 amp hour. So that's not, 10 hours to recharge fully or 9 hours a fully discharged battery. That's something to think about. I don't want to leave a gap when I don't have any power. So, but I've taken some steps against that. I'll talk to you about in a minute. Also, got to remember that uh, even though I'm recharging my batteries, my station is still using 9 amp hours. So every hour. So got to keep that in mind. Um, I could put 6 panels on the deck and get 300 amp hour batteries and probably do better. So, I put this bullet point in there to kind of, you can see the Franken project can run away from itself. Like, what makes sense and where should you stop? And that's another question I tried to answer. And so it finally occurred to me I could get a small generator. But more about that in a second. Yeah, 300 amp hour LiFePo 4 batteries, they make them. That's the maximum size. Lightweight, reliable. They're expensive. So, like for a 300 amp hour one, it sets you back more than $2,600. Is it really worth it? That might be a little overkill. And to really do what I want to do, I'd have to throw a lot of money at it. For people who are interested in more about solar power generators, LiFePo batteries, really getting into the details. I highly recommend this guy by the name of Will Prowse on YouTube, and just Google him, and you'll learn everything you ever wanted to know uh, on that YouTube channel. So he's my hero. It's just amazing what you can build, and you can save some money building your own batteries using raw cells and whatnot. I haven't done that. Maybe that's a project for the winter. Another thing I wanted to point out, the tariffs and whatnot that the government has established against China have really increased the cost of these things. So, that's the piper we've had to pay. If we use that technology, all these things are made, and not all of them, but a lot of them can be made in China. So, there's 10, 20% tariffs on some of this stuff now. One endpoint of my project was, well, what about field day? Wouldn't that be a great test run for this system? And what would it really take? 9.5 amp hours for 24 hours. I got to find 228 amp hours somewhere. I could get 230 amp hour batteries, 40 pounds each. Okay, I could put those in the RV. Just a variety of sizes and types are available. I beat that one to death. The other piece here is the power gate. So the power check that we showed you a minute ago, the other device measures rates of discharge and charge and all those minutiae. This device coordinates the power coming through your power supply. It's plugged into the AC. The raw voltage coming in from the solar panels and your battery. And so if the power supply is on, it makes sure that the battery is charged, and unless there's enough solar panel voltage coming in which case it'll use that. So this is got a built-in solar charge controller, and it uses MPPT, or the maximum power point tracking technology, which is the more efficient one. So on older stuff, or when you buy a solar panel, they include a charge controller. Those will be PWM, pulse width modulation units, and they're cheap, they're reliable, but they're not very efficient. But the MPPT is. So you really want to invest in that. And I was excited about it because this unit will handle up to 30 volts and 40 amps continuously, and it was perfect for me. The other thing that's good is it uses, I believe, MOSFET technology, and so the drop across from the battery to the output, the power supply to the output, the solar panel, is only about 0.05 volts. So it doesn't generate a lot of heat. The older ones did. I guess that's why they call it epic now, is because it's really cleaned up its act. One gotcha with this is that if you, by default, it defaults to SLA chemistry batteries to charge them. And LiFePo 4 batteries have special requirements to charge them. And those are set by jumpers, or I'll show you in a second, there's a USB cable you can connect to this thing and set those parameters manually. But if you power cycle this unit, like unplug all the power poles, it defaults back to SLA, which is no bueno. I mean, it just isn't proper for your battery. And it turns out that LiFePo batteries really want, particularly the ones from the BioInno company, and this may be true for most of them, I don't know, but they want to be charged at up to 14.5 volts. So, and if you get it too low, you're cheating yourself a little bit there. And but if you get it too high, you start blowing out equipment. So watch out for those things. Typical configuration, just to give you a visual of how this thing works. You can plug in the solar panels, the power supply, your load, which in my case is the packet station, and then the battery. There's an SLA or LiFePo 4 battery there. And this is just a screen capture of its logging capabilities and the things that you can set on the power gate. So, just what I told you, you set the different chemistries. You can set the voltage charge. So I have it at 14.5. I don't know, it likes to round things down by 0.01 for some reason. Max charge current in amps. It really likes 5 amps. I could put 10, but it doesn't seem to actually do that. It just does 5. I don't know why. And then it's got some smarts in it to not overdo it. It'll if it's not sensing the results that it thinks it should get, given you're charging your battery chemistry, you can set a number here. So after 1500 minutes, it'll stop. And then, do you want it to retry? Maybe the battery's getting warm or something. And you can actually attach a sensor to this, a temperature sensor. So on some battery chemistries, you really want to factor in how warm or not the battery is, and coordinate that with charge rate. So that's kind of cool. Now here's the answer to a lot of my problems. At the end of the day, this thing will make you feel secure and help you achieve your goals. These little generators are great. I know Dave, HDX, I first saw one in the wild at a field day we had some years ago, and I got one myself here. And it's just super fuel efficient, quiet. It weighs 22 kilograms, so it's not real light, but it's not real heavy either. It's a true sine inverter. And the other thing that's cool is you can take this and chain them together and you get 4.4 kilowatts. So this unit that they have now will do 2.2. I think the one that I actually have is the older version and only does 2. But so this really this will bail you out. So this is my backup and how I can run off the grid full time. Now my preference would be to do solar all the time, but I just came to the realization that it's going to take a lot of solar panels for me to pull that off. Well, here's something else. So the lowly cigarette, now we've got all this power. We're on batteries. One thing we can't overlook is how do we use and distribute that power. So, I mentioned I have a laptop, I have iPad. This thing, I think it's about a $60 unit, and there's a lot of junk out there. This is not made in China. And what's great about this unit is it has a USB-C slot, and I can recharge even my MacBook Pro with this thing, my laptop. It's solid. It's nice. It does all. I think it's up to 120 watts, so 10 amps at 12 volts. Yeah, another thing, you don't want to forget your cables. I just feel like the guy who has watches want to watch. I have just boxes and baggies full of cables everywhere, and it just seems like I need more all the time. but don't forget them because that'll put a stop to your de-expedition if you don't have them. So USB to Lightning to USB A, B, C, Micro, Mini, on and on and on. Anderson, MC4, it's all needs to be in your kit. So the other thing that's kind of sad is the very common cables. There's a lot of China junk out. I just call it China junk. I don't know. I just hate crappy electronic stuff. And I can't tell you how many cables I've gotten for my iPhone that just didn't do the trick. They would last for 3 or 4 months and then they quit. It's like, come on, guys, please somebody make a better cable. So be real careful. Always have. I guess the solution to this is you always want to have more than 2 or 3 to back yourself up. This is kind of a neat little device, and you actually have to have this to do some of the things I want to do. That device I showed you, that cigarette lighter, I would love for there to be a Anderson power pole power connector on one end and a USB-C cable on the other, but there is no such critter that I've been able to find, and I don't know why. But you buy this thing, you plug it into the Anderson power pole, and then you plug that converter, and then you can get from Anderson to USB-C power connector, and it works very, very well. Make sure in all this stuff I show you, you don't see any fuses necessarily in some of these products, but just fuse the living daylights out of things. Otherwise it's easy to start a fire. And you see in this picture here, the lower picture, I have my 30 amp hour LiFePo 4 battery in that box, and then on the front I mounted the power gate. And so the idea here is if I need to pick up my Go kit or my KX3, I can, so long as I have a checklist of all the pieces and things that one needs as a ham, then it works out great. Don't think that you can just eyeball it, because it doesn't work. On the other side of the battery box in the upper left-hand corner, I mounted a Rig Runner 4005, I think. So that's how I distribute the power around to the other peripherals. I tried to standardize on that as much as possible, including I built power cables to run my router in the shack here. My just about everything that makes sense to do that. It's kind of funny. I have a LED clock and I couldn't get it to work, and I called the guy, and he relies on this guy relies on 60 hertz signal to set the timers on the. That's another story, but I thought it was kind of interesting. Even though it has a 12 volt or a 9 volt connector, I couldn't get it to work off via battery power. So that was most everything will cooperate with you. Check computer. I love this thing. It's really, I wanted to be able to pick this up and go at a Go kit and want a big computer. Can run all the favorite software programs. You need to connect to the internet potentially, although that isn't always a feature. But you can tether it to a smartphone, and it just draws 2 amps no matter what you do on it. So that's great. And then, of course, there's another weird connector. So the bad news is it's a weird connector. The good news is it's just another weird cable, and there's no wall wart. You can plug in the USB-C into that bat power adapter I showed you, and plug the other connector right into the laptop, and it'll charge it. So I think on the new ones, the new Microsoft ones, they actually have a USB-C power connector. So, but I haven't tried that. So, did I achieve my goals? Well, these projects are always works in progress. I would say yes, as far as running my packet station. I think I could be able to run that certainly for 3 days, even if there was no solar. And if there is solar, it extends that period. And because I have the power check unit, I can see how much in the hole I am, or if I'm running my battery down. So in the summer, it runs fine. I probably need to add a panel or so to just run it indefinitely all year round. But I'm pretty close to being able to do that. Being able to run my packet stations continuously forever, yeah, not quite. So I would say no, I haven't achieved that yet. Be able to recharge basic electronics no matter what, yes. Be able to recharge my laptop computer, yes. Or anything else around here that wants a charge. Upgrades to the system. Well, if I had an unlimited budget and more spherical cows out there, I guess. So those LiFePos come in sizes from a few amp hours on up to 300, and they're expensive, right? So I'm not going to do that. The cost is about $8 to $10 per amp hour, but you can use 90% of the battery, so that's the big win, and lots of cycles. Could add a few more solar panels to the deck. I've considered whacking my trees. I just can't bring myself to do it because I'd probably save more money cooling the house in the summer. But man, I don't know. So another thought was to put a tough shed out in the middle of the yard, which gets an insane amount of sunlight. I mean, I sit on the deck and I watch the middle of the yard and I think, that really needs a tough shed in it, and mount some extra panels to that to accommodate the huge losses. So, maybe if I build a tower, it's equidistant between the tower and the shack. So the losses, okay, I can kind of start to balance all these factors. But you could run rotators and stuff. I mean, it's endless. So you got a big enough shed, you can put up maybe 15 panels, and you'd have plenty of power to meet this goal. That's just the bad news, right? This is all the money you can spend. So I'm a bit of a prepper, and I like to be as self-sufficient as possible. And I'm learning a lot of all different aspects of this. So the generator, what I'm trying to do is justify to you spending that kind of money on the generator and some of this stuff. But when the power is out and you really need to run some stuff, it's valuable. If anything, I might upgrade that at some point to a bigger unit. The Powergate stuff, everything's is what it is. I might consider getting some better panels. That might be an easy win. That's really all I have to say. Most of the money here is between the generator and the LiFePo batteries. So that's just what you're looking at. On the other hand, you can spend. Here's how you can justify it. It's like, well, I could buy another radio, or I could just buy some batteries. So, all these thoughts go through. I could do a presentation on the psychology of a ham and the YL, right? So, we could all talk about that. All right, well, that's the presentation. A lot of fun. I encourage everybody to use their COVID time if you have some, and do a ham project and try to collect some data and share it with your club members. So that's
Robert, you got one question here.
Okay.
Thomas King asks if any heating issues having your batteries in a container.
I haven't had any. But then I'm only drawing 9 amps at most at a time, so have not had a problem.
Okay, and another question is any RFI issues?
No, and probably because I use MPPT. If you use PWM pulse width modulation, you can definitely get that. And that has some of the Powergate stuff, the older stuff. It was a concern. It did generate some RFI, but the new stuff doesn't. Haven't had any problems with it. So
okay, let's see here. Randy, let's see. K0TNG says I repurposed old DirecTV mounts for my panels. Mount those to concrete outside my shack. They're adjustable.
That's a good idea. Yeah. I mean, I think there's a lot of room for creativity. Too bad that's not like the $800 thing, huh? So I'll do that.
And Jeff is saying also for everybody, for a copy of the presentation that Robert just did, to send an email to kb0cht@arrl.net. So kb0cht Charlie Hotel Tango at ARRL.net, and Jeff will fix you up.
I'll send him. I did a few edits, so right after this, I'll send him the updated version. So
Okay.
all right.
Any other questions out there? Well, I think we had 56 or so people on at one time. We're down to about 46 now. So
Oh, wow. Okay.
very interesting presentation, Robert. We thank you. You've done a lot of them over the years, and we always enjoy your subject and your humor. So thank you very much.
Yeah. So thank you.
One thing I had, it's not nearly what I've got one of these little things from PowerWorks. If you can, well, I guess you can't see through mine.
Oh, yeah.
And it'll do part of what it'll do: amps, volts, watt hours, and watts. And it's about $50, but it won't do all the stuff that yours will. But I think it's $49. You can get it with flying leads or with the like this one has the power pole. So just for gee whiz.
Yeah. There's yep, those are good.
Okay, let's see. Jeff said great presentation, thank you. And I think we all say that. So last chance for questions. Or any other club questions or anything for me? Other than that, we'll kick you all loose and see you on the Sunday night net. And like I think Jerome said earlier, don't forget about Wednesday evening at 7:30, 8:30. Which is it for the learning net, and especially any new guys. That's the place to answer no dumb questions. Just come on and typically a lot of times Larry's on there. Fred's usually always there. Jerome's there. I try to when I can.
Jerome says 7:30.
7:30. Okay, yeah. Okay, 7:30. 7:30 on the any Wednesday evening except our meeting night like tonight. So okay. 7-3 to all. Thank you, Robert. We'll see you later. Bill, everybody, adios.